All right. Before we start, any questions about anything we've been working on? Probably like visualizations or pandas. Awesome. Okay, because we're going to dive into something completely different from what we've already been doing, which is SQL. And so SQL is a completely different language from Python. For your information, actually, SQL is not typically used in Python, as in like we don't typically use SQL with Python. It's just that since we've already been using notebooks, it's just easier to do it this way. I'll explain more later. So SQL is a database querying language. So imagine you have a large database with like, let's look at this. This is an example of a database. And this is a database of, I'm guessing, employees. And you have a table of all their employees with their like first name, last name, gender. You have their job titles. You have their salaries. You have their departments, their managers. You have like a bunch of tables. And what SQL is for SQL is used to get information from all these tables in a nice synthesized way. And I'll show you examples towards the end as well. So really quickly, what is a database? It stores sets of data that can be queried or used in other applications. And there's a database management system that supports the development and admin and use of these database platforms. So SQL and SQL databases are relational databases. I actually don't use this acronym that much. We usually just say relational databases. But they are row-based table structures that connect related data elements and include functions that maintain security, accuracy, integrity, and consistency of data. The important part is that they are all tables, and tables that can relate with each other. So for example, in this case, you have employees that have like their, probably their employee number, which is an integer. I'll explain all of this in more detail later. But here you have like their employee number. In titles, because this is just a table of job titles, you have the employee number again, and it tells you your title from what date to what date. So for example, let's say you have one employee that has been promoted a few times. It doesn't make sense to just have that employee turn up like multiple times in this employee table. But in the titles table, you might have just that employee number, title, and maybe like 2014 to 2016 this title, 2016 to 2017 this title, so on and so forth. So it's relational because you can join these tables, very similar to what we were doing in pandas, based on their employee number. That's a specific example of like how tables are relational. All right. So what is SQL? Some people call it SQL. I've mostly heard it called SQL. Stands for Structured Query Language. So SQL is the language that we use to query SQL databases. It's a programming language used to communicate with data stored in relational database management systems. And I was saying that SQL is usually a lot easier to pick up because it is very similar to the English language, which makes it easy to write, read, and interpret. So this table that I was talking about, every database that is well maintained and well organized comes with a schema. And a schema basically tells you what columns exist in the database and what tables and what columns exist in the database. So I guess one thing I should mention is the structure is you have the largest unit you have is the database. Within a database, you have multiple tables. And then within each table, you have your data, your rows. So anyways.
One quick question. Is there a way like where we find info, right, in pandas or anywhere?
Yeah.
.info, and then like we get some kind of
Oh no. All right, let's see if we can come back. But yeah, it's very, very similar to doing a .info. If you remember, if you do a df.info, you get every single column with like how many non-null characters there are or how many non-null values there are. Sorry, Kishore, I'm gonna mute you for a little bit.
You sure can't hear you. You'll break it up.
Can't mute his video either. Sorry, you guys. I think it was lagging from before. All right. All right. Let's see if he comes back. Anyways, as I was saying, very, very similar to doing a df.info. And usually in a schema, it tells you each column that's in this table, and also the data type. So that's also really useful because, for example, here it says you have integers, you have date objects. So date is actually a data type as well. Varchar is basically a string. I think it stands for variable character. But yeah, schema is really, really helpful because SQL databases can get really, really large. So there's that. Important to always check the schema because it just makes your life a lot easier. Next, it's really important to understand relationships when we talk about relationships between tables in your database. So there are 3 types of relationships. First, you have a one-to-one relationship, one-to-many, and then a many-to-many. So when you have a one-to-one relationship, very straightforward. One customer only has one address. That is a one-to-one relationship because one customer can only have one address. Very commonly, you have a one-to-many relationship where, let's say you have a table of customers and their orders. One customer can have many orders. So that's a one-to-many relationship. Finally, there's also many-to-many relationships where you have like a bulk of items and you have a bulk of order, and each order can have some subset of the items. And so here you can see that, okay, order 2 has item 2 and 3. Item 3 can be part of order 2 and 3. So this many-to-many relationship is a little bit more complicated because we need a separate table to track the relationship. So usually if you have a many-to-many relationship, there's usually a third table that exists. It's called a junction table. These definitions are a little less important right now, but what you would have is you would have another table in between them basically to track the many-to-many relationships, such that instead of having just many-to-many relationship between two tables, you would have 2 one-to-many relationships between, or in this case, the order and this item order table and item to item order table. This gets into a little bit of like database theory, which is not super important for us right now. But always good to know that these are the kinds of relationships that can exist. All right, really quickly, there are a bunch of SQL data types. The main ones that we're going to talk about, I have this here, and feel free to read through in the notebook that I uploaded. But main SQL data types, let's zoom in over here. You have text, like for example, names. You have numeric ones, for example, like floats. You have integers, and integers are different from floats. Integers are the ones without decimals. Real, I think that's real number, and also blob. Blob is kind of funny. Blob just means when you have a lot of text. So if you have regular text, there's actually a character limit. I don't know off the top of my head what that limit is, but if you have like long pieces of data, in terms of like maybe you have like a long paragraph in terms of like a summary for something, it would be stored in a text blob. Any questions so far? I know I just like dumped a bunch of new things, so just like let that sink in. Shoot any questions you have in Slack. Awesome. All right, so as I mentioned before, we don't typically use SQL and Python. Usually what you have is when you have, if your job in the future is working with SQL, very often you would be working in some sort of SQL software. For some reason, my work computer didn't allow me to download any of this software to demonstrate, but there's this one software called Mysql Workbench. And what you can do is you just navigate to the database folder or the database file, and then you can just plug in and then you can type queries directly in there and save those as CSVs for you to do whatever analysis you need. Just to show really quickly over here, I have the database right. I think I put it in here. Nope. Let me find that database. I just want to show you guys what a database file looks like. And it looks like I put it, I had, give me a sec. I just need to move the database file back here. All right, so let's refresh this there. So database file is something that ends in a .db, and I already have this here. So what you would do is you would take this file, put it in whatever SQL software you're using, and you can query directly from there. But because we are Python developers, there is a way to just do that within Python. It's going to be a little bit finicky, but it's actually pretty, you get used to it. All right, so we're going to be playing around with this pretty simple Pokemon database. I don't know why, but a lot of people at Flatiron School just love Pokemon. I am a huge Pokemon fan myself. But anyways, this is the database that we have. So here we have a Pokemon table that has each Pokemon's ID, name, height, weight, their experience. There's different types. There's different Pokemon types. And this is what was called the Junction Table that I was talking about earlier, because each Pokemon can have multiple types, and each type can be part of multiple Pokemon. So that's a many-to-many relationship, which is why we have this Pokemon types junction table here. And then we have this types table over here that is just the ID of the type and the name of the type. So to use SQL in Python, SQL is tables. And we've just been working with a bunch of tables with pandas. And so what was done is that you can interact with SQL and then port that data straight into pandas. So for this, we're going to import pandas and then also SQLite 3. Let's do that real quick. All right, so the part that gets a little bit finicky is that we have a database and then we have our Jupyter Notebook. Our Jupyter Notebook doesn't necessarily on its own know how to communicate with this database. And so what we can do is use something called a cursor to connect to this database. Yeah.
Could I ask a quick? Is there a reason we don't give SQL or SQLite a abbreviation or nickname?
I don't know, honestly. I think SQLite 3, because it is not used very often, is not used as often. Like in Python, NumPy, pandas are used so often, whereas for SQLite 3 is more specifically for us data scientists. I think maybe that's why. But yeah, I have no idea why we don't. I think maybe because out of SQLite 3, there are not a lot of like methods that we're using. So you know how in NumPy we have to do like np dot things a lot, but the SQLite 3 that we import here is just used for this one thing. It's just used for the cursor. And once we use SQLite 3.connect, we don't actually have to use anything else from SQLite anymore. So I'm guessing that's why, but I actually don't know. That's a great question. So as I was saying, for our Jupyter Notebook to communicate with the database, we need to create this cursor object. And what you do is it comes from the SQLite 3 library, and then you're connecting to the database file. And there is actually different ways that people use. There are different variables, like you know how data frames are generally df. In terms of connection, like the cursors, I've seen a lot of people use CNX, which stands for like connection, or I've seen a bunch of people use cur, like CUR. I don't know if there's like an industry standard, but in this case, I don't really think it matters too much. All you have to do is just run this connection, and then now if you use CNX, it will just automatically connect with your database and you're able to run SQL queries. So really quickly, we see that we have pandas. I'm going to explain this really quick. I'm going to run this and then explain really quick what's going on here. So here I have a query, and I'm going to explain the structure of our query later on. But basically what we're doing here is we're selecting star from Pokemon. Star is just the symbol for all. And so I'm basically just selecting all the data from this Pokemon table. And that's my query.
Wait, for some reason in my file, when I download, I didn't get the Pokemon data. There's just a placeholder. Anybody else have that?
I'm going to, I'll have to check on that after this, and I'll let you guys know. All right. Yeah, I think because I also didn't have the database file there. So I'll check on that and upload that straight away. Anyways, so I have the query as a string, and then Pandas actually has a really handy read SQL method that takes in 2 arguments, the query itself and the cursor object. So that's why when I run this, we get this data frame in like a format that we all know and love. So that's how we sort of interact with SQL through Python. Questions? All right. So parts of a SQL query. I think I mentioned this earlier, but with SQL, there's not too many things to learn. It's just how you put them together. And so these are just like the most commonly used keywords. And then all you have to do is just put them together to query exactly the data that you want. And so when you're querying, you're basically joining tables together or like filtering out the specific information that you want, giving them specific conditions. You can order them, and then you can even limit to like how many results you want back. So main ones to start, select and then from. And every SQL query starts with a select from. So the one that we just did earlier, select star from Pokemon, select everything. We would just select star from Pokemon. So you would select here. What you would do is you tell it which columns you want. And star is just all columns. And then from Pokemon, which table. So let's take a look at this schema again. We have 5 columns here in the Pokemon table. And let's say we just want to get ID and name. To do that, pretty straightforward. It reads just like English, ID, comma, name from Pokemon. And you see when I run that, it only returns our ID and name. Really quickly, because this outputs a data frame, let's say you are given a SQL database and you need to do analysis in Python. I can literally take this and save it to a data frame and then start working like we've been working with databases. So the querying is really just a matter of getting the data in a format that we like. So yeah, just wanted to highlight that. Cool. So the next part of a SQL query is a where clause. And so where is where you define the conditions to filter your query by. So let's take a look at this next problem. It says, find all the rows from the Pokemon types table where the type ID is 3. So let's take a look at the Pokemon types table first. Let me do this. Actually, I'm just going to call this test. And let's take a look at Pokemon types and see what that is. So let's do select. Oh, and SQL is not case sensitive, but by like convention, keywords are usually in all caps. So select from Pokemon types. And then let's do pd.read SQL test and the connection. Awesome. So here we basically see that this is just a table that associates each Pokemon ID with its type. So I guess this also helps to just show what this junction table is doing. You can see here the many-to-many relationship because this Pokemon 1 has type 12 and type 4. does everyone understand like what this Pokemon types things means? Because once I was explaining this and someone's like, what is a Pokemon type? All right, so I guess for context, Pokemon are these little monsters and they have like different types based on like the kind of monster that they are. And so they can be like a water type or a fire type or a grass type. And so there are like it gets really complex. But yeah, this is basically what that means. So this Pokemon 1 has 2 types. And you can see 12 has been coming up a bunch, right? So that means, I'm pretty sure this might be grass type, but you can see like Pokemon 1, 2, and 3 have type 12. So that's why we need this, or we don't need it, but this table just makes it clean. It makes all of our tables cleaner so that we don't have like duplicates in each of like the type tables or like the Pokemon tables. Does that make sense? All right. So this is the Pokemon types table, and they just said find all the rows from that table where the type ID is 3. And so how we do that in a SQL query, we're selecting all from Pokemon types where type ID equals 3. Just like that. Very similar to English. And you see here all the types that come out, all type 3. The thing with SQL, I think, is mainly just getting used to it in practice. I think SQL itself is not too hard, but yeah. All right, so find all the rows from Pokemon types table where the associated type is water. And so here we don't know, like based on this Pokemon types table, which one is water, right? Like we don't know which number refers to water. And so we might need to take a look at a different table and like help us out. So looking back here, we have this types table. And so what we're gonna do, I usually would have done this at the very start, but let's take this type one and let's just take a look at our types table. Cool, awesome. So here we have everything from the types table, and it's literally just like a number and the name of the type. So what we're gonna have to do is we're gonna have to find a way to get all of this information with that Pokemon types table. And so as we talked about briefly with pandas, we do a join. So every time there's like the number 3, it's gonna have this flying column. It's gonna append flying to that row. Every time there's an 8, it's gonna append ghost to that row. So how we do that is with a join statement, which is what we were doing with pandas. Pandas, it was like either the concat or the merge or the join, but in this case, it's just join. So here, this gets a little annoying because it gets really long in Python. It's hard to see, but how we do. So anyways, what we're doing here is we're selecting Pokemon types dot star. I'm going to explain why we have to do this in a little bit, but we're selecting these columns from Pokemon types, and we're doing this join. So the join here, let me make this clearer. All right, so we're joining types on types ID equals to Pokemon types dot type ID. So to break this down, join always comes with an on. Between the words join and on is what table you want to join. So here, because we're querying from Pokemon types, we're joining the types table. And then you have to tell it which columns to match up. So we're taking types.id, which is here, types.id, because you want the ID column, equals to Pokemon types.typeid. So if we look at the Pokemon types table again, you can see that we have this type ID, and that is the column that we want to join on. It would be easier if I just have both of them here. There we go. So here we want, from types, we want to match this ID column with the type ID column here. And that's how we construct the join statement. So types ID equals to Pokemon types type ID. So that's another part. That's the join part of the statement. And finally, after joining the tables, you want to have that filter where types.name equals to water. And that's just the same as what we were doing before.
You could, I guess, break that string down into, to look more like a for loop, right? Couldn't you?
Look more like a for loop. You mean like if I put it in like multiple lines? Or
Yeah.
like, oh yeah. Yeah, you could totally do that. I think you like use a symbol like that and it like continues. Yeah, you can totally do that. I just find it like kind of, I personally don't do that, but please, it just makes it easier to look at for sure. But anyways, yeah, actually that's a good idea. Let's separate it like this. So we have the join, we have the select, we have the join, and then we have the where. Okay, so back to this part where we're doing Pokemon types dot star. Whenever you're joining tables together, if you do a join, it's gonna return you every column. So actually, let's take this away first. Let's take away this where clause. All right, let's take a look at what this looks like. So now we have the Pokemon types and the joined type ID. So these are just Pokemon. Hold on a second. Types on type ID equals to. Give me a second. This is not showing what I wanted it to show. Right. Oh, sorry. If we don't have this, this is what I meant to show. If we don't have that, if we just do star, that's what I wanted to show. If we just do star, it's going to show all of the columns from all the tables. That's what I wanted to show. Sorry, you guys. It's been a long day. So we, in this question, they just said, find all the rows from the Pokemon types table where the associated type is water. And so I guess you can, the way that this query was constructed, you just wanted to see only the columns from that initial Pokemon types table. That makes sense? So you would do Pokemon types dot star, and that only gives you the columns from that Pokemon types. Because we did the join, it's going to show all the columns. Cool? I need to use select star. And then, yeah, where types.name equals to water. I also wanted to show this part. Comment this out. That before that, it would join all the IDs together. So because the type ID here is 12, it would do grass, as I was mentioning. It would just match up the tables based on like those two ID columns. Cool. Next. This question says, find the average weight for each type. So you can see that like each type is associated with a bunch of different Pokemon, and you just want to find the average weight of the Pokemon with that type. And then order the results from highest to lowest weight, and then display the type name next to the average weight. So cool. A lot of stuff happening here. I'm gonna take Edward's advice and split this up so it's a little easier to see. Oops. And then here. There we go. There's a bunch of things happening here. So first, we want all the information from all the tables because we want the type name and we want all of the Pokemon. So we want the Pokemon information and we want the type information, so therefore we're joining everything together. So what we do is we're selecting something, and I'll get back to that in a little bit, but we're gonna select from Pokemon, and then we're gonna join the Pokemon types, and then join the types table. Cool. So what's happening is we're starting from this table. We're going to join this table, and then join this table. Because we can't just join these two because there's nothing that associates the two of them, which is why we have to do the double join, because we want to join this table and then join this table. Cool. Because from here, we will basically find out what types the Pokemon have, and then we have to get the name of the types. All right, so back down here. All right, so we're doing 2 joins here on the ID columns. Next, we want to find the average weight for each type. So now what we're going to do that is a little bit familiar from pandas, hopefully, is we're going to do a group by. And we're going to group by what type it is. In this case, I'm grouping by types.name because in the types table, which is here, in this types table, we want to group by the name column. So it's always handy to have your schema opened up next to you. But yeah, we want to group by the types, which is why it's types.name is what we're grouping from. And then, if you guys remember that whenever you do a group by, you always have to do an aggregation. And that's where we come back here. The aggregation must be at the start. I know it's a little bit backwards and a little bit confusing because you have to know what you're aggregating, but you're selecting the aggregated value here. So here we're selecting the average weight and types.name, which is the name of the type. Questions? Yeah. Anyways, so we're doing that group by, and then we're just going to sort it because it says order the results from highest weight to lowest weight. And another keyword is you can use order by. And here we're going to order by. And when you do an order by, it has to be something that you're querying. Usually it's something that you're querying. So we're going to order by the average weight descending. So this is typically like the structure of a SQL query. You're just like many little parts put together. But anyways, here we have it. As you can see, each type has an average weight. Well, I'll say that later. Cool. So now I'm just gonna do a bunch of examples for this, and hopefully things start to make sense. So here, find the names and IDs of the Pokemon that have more than one type. All right, so this is another one. Let me do this split up thing again. All right. So now we only care about the names and IDs of the Pokemon that have more than one type. So we don't really care about the name of the type, which is why we're only doing one join. We're only joining on Pokemon ID equals to Pokemon types dot Pokemon ID. So here, because we know each Pokemon ID here has multiple types, we're going to group by them. So as an example, here, Pokemon 1 has type 12 and type 4. Once we group them together, and if we use the aggregation function of count, it'll just count up how many types each Pokemon has. Does that make sense? So let's say like if Pokemon 100 had 3 different types, you can do a group by, and for Pokemon number 100, if you group by and aggregate it with a count, it'll come up with a 3. So let's go back to that. So we're going to group by Pokemon ID. And then, because we want to find the names and IDs of the Pokemon that have more than one type, we're going to give it another condition. And here's where the having statement comes in. So the where statement that we talked about back in like question 2, and yeah, back in question 2, that's for conditions. Having statements are for conditions after a group by. I don't understand why they did that either, but you only use having, or having will only work after a group by, and if you change this to where, it will also not work. So where is before group by, having is after group by. And then you just want to see where that count is more than 1. So let's take a look at that. So these just happen to be the Pokemon that have more than one type. If we get rid of these and put a star, we can see what was happening here. So we see that these columns, these 5 columns came from the original Pokemon table, and these came from that second table. And we did the join on this column and this column. So this ID column and this Pokemon ID column are the ones that match up. And then we grouped by the Pokemon ID. And then we did the count. So therefore, we're just counting how many, yeah. So that's why each ID for each Pokemon only appears once. Cool. And if we get rid of, this part, if we get rid of this part, you can see that every Pokemon turns up, and the counts come from, if I do count, I can also count all. So if you do this, you can see like each Pokemon and how many types each of them has. Does that help and make things a little clearer maybe?
Where in the database that show the, I thought it was only one ID per Pokemon, but now you're saying they have more than one ID sometimes, more than one type?
Ooh, yeah. So yes, because in this table, in this Pokemon types table, where is that Pokemon types table? In this Pokemon types table, you have multiple Pokemon IDs.
Oh, okay.
Yeah, so that's how it gets duplicated. Yeah. It's kind of confusing. I will send you guys a super great resource for like getting SQL, like understanding SQL. Let's undo all of this. Cool. So these are basically all the Pokemon that have multiple types. And last one, find the ID of the type that has the most Pokemon. And then it says also to display type ID next to the number of Pokemon having that type. All right, so let's split this up again. This and this. Cool. So here we're doing a count again because we are looking for like the type that has the most Pokemon. So we're gonna use the count. And then we can also, and we know we want to group by the type ID because we want to just group by the type. And then we just need to order by the number of Pokemon descending, and then limit one because they only care about the one that has the most Pokemon. One new thing that was introduced here is aliasing. So here we're selecting count Pokemon ID as num Pokemon. So that just changes the name of the column that comes up. That's literally all it does. So what we're doing is we're selecting the count as num Pokemon and also the type ID. Let me just output this to see what this was. So that is, so type ID of 4 has the most number of Pokemon. Let me take away this limit so we can see more. These are basically each type and the number of Pokemon associated. I can call this column anything I want. I can call it Pokemon count, and you can see that this will just, oops. Because I have to change this as well. There we go. And that's how you alias column heads. You want to do this sometimes. A good example was earlier here when it just says average weight. You can do something like as, and if you want to just make this formatting a little nicer, you could do like average weight or something like that. And there we go. That makes sense? Yeah. So that's pretty much all of the must-know SQL things. Do you have any questions so far before I show you guys a bunch of resources, or a resource that I really like, which I think some of you might guess already?
Okay, so I had lost the connection.
Yeah.
When the explanation was on. So that is one question. Secondly, what happens when for the data cleaning part?
Yeah, so ideally, if you if you're getting your data from SQL, your data should already be like semi-clean. Because the way that companies work is they will get their data, port it into SQL, and in between that portion, they would probably clean as much as possible. Sometimes the format of the data that you get from SQL is not the format that you want. So then you just do your own cleaning. So let's say maybe you just don't like to see these numbers, and you just want to replace these numbers with like the actual like names and like the actual types, you can do that. So it's really, yeah, the cleaning part is up to you, because once we get the data from SQL, port it into a format that we know and love, pandas, we can do whatever we want from there.
Okay.
Cool.
Yeah.
Any other questions?
Yeah. So first part, I'll check it on the video then.
All right. Yeah. I think you were talking about how schemas are very similar to using df.info.
Yeah.
The schema graphic I have is over here. Yeah, and it is very, very similar to using a df.info, but I would say maybe better because you have all the tables there. And these lines actually tell you the relationship between the tables. So here you can see that this basically means a one-to-many relationship because one employee can have many titles. Cool. Any other questions?
Yeah. So here, I mean, while calling for it, we can always call it for like after we have converted into pandas, and then like you do it as df.info, or before that you can do something where you can call it.
I mean, it's up to you. Like, let's say you get a lot of data from SQL. I can do a df.info on this as well. Like, imagine if this was bigger, I can do df equals this, and then look at df.info. And you see the same usual output. Yeah.
Okay.
Is it something? So really quickly, I wanted to show you guys the way that I actually learned SQL, and I think is really great, is through HackerRank. HackerRank has a really, really great SQL series. It's how I learned SQL, and they have an entire series of well, these are like really basic, like select query. You can choose like what things you want to practice. And they have this entire series called Weather Observation Station, which is like a increasingly difficult series of questions of like how to query. And the really great thing about these questions is that all you have to do, you don't have to worry about the cursor. So one thing I also want to mention is that there are different kinds of SQL. For the SQL that we use mostly is MySQL. And so what you can do is you literally just need to do the select star from station. And then, yeah, you don't have to worry about all that cursor stuff. And also, as Edward was saying, yeah, that's not the right answer. But if you need to do things, you can, it doesn't matter how many lines you use, where, I don't know, whatever condition, and then you can like group by, and you can do that. And so like the number of lines that you use for your query doesn't matter. So I think this is a much easier way to practice SQL than having to worry about like the strings and the cursor as well. Cool. Any other questions? Yeah, the next couple of study groups are going to be a little bit all over the place. On Monday, it's going to be a different kind of database structure. And then after that, it would be getting how we get data from the internet. And then we get to our projects. So that's exciting. But for project one, really the main focus is pandas and visualizations. Cool. Any last questions? If not, we can get about 10 minutes back.
So in the project, what happens? So if we are going to import from the internet itself all the data, or it's like they are the existing data which is there, and then from there we are going to work on it.
Yeah, you're going to be provided your data. The data will be provided. You'll probably do like import CSVs for all the data, and you're gonna have quite a few tables, and then you'll just work from there.
Okay.
Awesome. Any final questions? All right. If that's the case, have a good night, everybody. I have a bunch of one-on-ones with a bunch of you tomorrow, so I will see you there. If not, I'll see you next week. Have a good weekend, everybody. Bye.